Today we are going to solve inequalities using addition, subtraction, multiplication, and division. To solve an inequality, you do the exact same thing that you do when you solve an equation. Our goal when solving an inequality is to get the variable by itself. To do that, we use the inverse operation or the opposite operation. The difference is when you have isolated the variable, it's not going to say x equals 3. It will say x is greater than 3 or whatever inequality symbol you have in there. That means the solution is not just one number. The solution is every number that makes the inequality true. You are going to show that with a graph. Let's quickly review how to graph an inequality. If you are given 3 is greater than x. Now, we have the number first and the variable second. It is my recommendation that anytime you have the variable second, you switch it so that the x is first. Now notice it's pointing at the x, so it still needs to be pointing at the x. And then the number second. It makes it easier for graphing, and then you make much less mistakes. So 3 is greater than x, gets flipped over, and its x is less than 3. We draw our number line. Have arrows on the ends of the number line to show that it goes forever and ever. I always put the solution in the middle. 2 bigger numbers to the right.
Good morning, Bobcat.
And to the left, we put 2 numbers that are smaller. We have to decide if our dot is going to be opened or closed. Because our inequality symbol does not have an equal to, that means it's going to be open. And then we have to draw a line in the direction that x will be. So x is less than 3, so you have to draw a line showing the numbers that are less than 3. Everything on this side should make the inequality true. So try one. 2 is less than 3. That's true, so we know that our graph is right. It's an open dot because now we know it goes up to 3. It can go up to 2.999999, but it cannot be 3 because it's not filled in. Because 3 is less than 3 would not make it true. Okay, let's solve some inequalities. If I have, for example, w plus 12 is less than or equal to 20. I am looking at this problem just like I look at all the other ones. I'm still going to draw my line down the center of my inequality. I have to get w by itself, so I have plus 12. I'm going to subtract 12 from both sides. Positive 12 and negative 12 cancel out. I have w less than or equal to 20 and negative 12, or 20 minus 12 is 8. So w is less than or equal to 8. I ask, is my variable first? It is. So because of that, I am ready to graph. W is less than or equal to 8. I have my line, the arrows on the ends. I have 8 in the middle. 2 bigger numbers ahead, 9 and 10. 2 smaller numbers to the left, 7 and 6. I check if it's open or closed, and because it has the equal to, I know it's going to be closed, because it can go up to 8, and it can be 8, and w is less than, so these are the numbers that are less than. 6 is less than or equal to 8 is true, so I know it goes the right direction. You have to have all of this for your solution. So you have to make sure you have both the inequality and the graph. Next example, please pause, try it yourself, and then come back and check how you did. We are going to do 18 equals 9x x. Oh, I'm sorry, it can't be equals. 18 is less than 9x. All right, try it out. Okay, so when you're solving this, you want to get the variable by itself. So I'm going to draw my line in like I always do. I know that I need to get the x all by itself. So to get rid of that 9, I know 9 is multiplied to x, so I'm going to divide by 9 and divide by 9. My 9's cancel out, and I have x, same exact symbol, and then 18 divided by 9 is 2. Now in this problem, I have my variable second, so I am going to change that. I'm going to put the x first, and then the 2 is second, and then it's pointing at the 2, so I'm going to make sure it's still pointing at the 2. When I graph this, x is greater than 2. I have the 2 in the middle, 2 bigger numbers to the right, 3 and 4, 2 smaller numbers to the left, 1 and 0. I check if it's going to be open or closed. In this case, because it's not equal to, I know it's going to be open. And it says x is greater than, so my arrow will go to the right because those show numbers that are greater than. Again, you need to make sure you have all of this for your solution. All right, let's quickly do 2 more and then a couple story problems, and then we will be done. All right, if you are looking at, for example, (24) is less than or equal to W minus 12. Try it out. Okay, so I draw my line down the middle. I want to get W by itself, so I know I'm going to add 12 to both sides. 24 plus 12 is 36. Less than or equal to W. The 12s cancel out. I again notice that my W is on the right side of the inequality. I want it first, so I'm going to put W first and 36 second. I see that it's pointing at the 36, so I'm going to make sure it's still pointing at the 36. Now, it doesn't matter that the numbers are huge because we're just going to put our solution in the middle. The 2 bigger numbers to the right, 37 and 38, and the 2 smaller numbers to the left, 35 and 34. I'm going to decide if it's open or closed. This one is closed because it is also equal to, which means it can go to 36 and be 36. And then it says W is greater than or equal to 36. The numbers that are greater than are to the right. 38 is greater than or equal to 36 is true. Okay, last example. Let's say I'm looking at x over 7 is less than 10. Try this one out, see how you do. Okay, so I have my line down the middle. I see that this is x divided by 7. To get rid of something that's divided, you need to multiply. So I'm going to multiply this by 7 over 1. And the same thing on the other side, 7 over 1. Because my 7's cancel out, and I'm left then with x over 1, which is just x is less than, and then 10 times 7 is 70. My variable is already on the left side of the problem, so I don't need to worry about that. Draw my number line, put 70 in the middle. Bigger than 70, 71 and 72. Less than 70, 69, 68. I decide if it's open or closed. In this case, it's open because it goes up to 70, but it is not equal to 70. And its x is less than, so I look to the left. I try one out. 68 is less than 70. And I know that that is true. All right, let's try a couple real life situations and then we'll be done. So take a second to copy this example down. An amusement park sells ride tickets for $2.50 per ride, or $15 for an unlimited pass. How many rides would you need to go on in order for the pass to be a better deal? So what we have to realize when we're talking about this is that to be a better deal, you have to start getting free rides past the $15. So if the number of rides you go on is equal to 15, it's not a better deal yet. The number of rides you go on has to be more than 15. So to be a better deal, you have to think about this. It's $2.50 per ride. So you would have $2.50 per ride. And for this to be something you don't want, it has to be more than $15. Then the number of rides you go on will be a better deal. Okay, so we want to solve this then. We're going to draw our line down the middle. We see it's 250 times R. I'm going to divide by 250 and divide by 250. Do the division off to the side. I have 15 on the inside and 250, or I can just use 2.5 because that 0 in the end doesn't mean anything. I have my decimal here. I'm going to move this over one time, move it over one time, put my decimal straight up. So I'm really doing 25 into 150. 25 goes into 150 7 times. So that is 150. I'm sorry, it's not 7. I caught my mistake. 6 times. 6 times 25 is 150. So what that's telling you, that if you go 6 times, it's going to be 15 basically, because 6 times 25 is 15. We want it to be greater than 6 because 6 times would be equal the amount. If you go 7 times, now you've only paid $15. If you went ride by ride, it would have been $17.50. So we're going to say R has to be greater than 6 for the pass to be a better deal. And the graph of that looks like this. It's got to be open at the 6 because 6 would make it equal. You don't want that. And the number has to be greater. So if you plan on going on more than 6 rides, you should buy the pass. Okay, let's do one more. Okay, take a second to write this down. Students at a playground are divided into 5 equal groups with at least 6 students in each group. Write and solve an inequality to represent the number of students at the playground. Okay, so they're divided into 5 equal groups. So when you think about it, that would be the number of students divided into 5 groups. Now what we have to do is decide. It says with at least 6 students in each group. That means there are going to be 6 or more students in each group. So that this has to be greater than or equal to 6. Because this division problem, and you know what, I'm going to use a different variable because it looks like a 5. This division problem, I'll use P for playground, has to show the number of people on the playground, students on the playground, divided into 5 equal groups, has to give you more than or equal to 6 in each group. Take a second to solve that. Okay, this is a division problem. We know that we're going to divide. If it's division, we multiply by 5 over 1, so they cancel out, and multiply by 5 over 1. So it shows that P, the number of people on the playground, has to be greater than or equal to 30 for that group size to happen. The graph of it looks like 30 in the middle, 31 and 32 to the right, 29 and 28 to the left. This one will be closed because it said it could be equal to 6 in each group. And it has to be greater than that because it could be more than 6 in each group. Your sentence then would say, there will be 30 or more students on the playground. Okay, once you have that down, we are going to try and work on this on our own. Make sure you ask questions if you have them. Thank you.